Good evening. I'm Jim LeDuc, and I'm the director of the Galveston National Laboratory, located on the campus of the University of Texas Medical Branch. Once again, UTMB is pleased to partner with the Space Center Houston in sponsorship of this fantastic Thought Leader Lecture Series. For the last many months, my colleagues at UTMB have been 100% focused on learning everything we can about the virus that causes COVID-19. We're fortunate to have high containment laboratories where scientists can work safely on the most dangerous viruses in the world. And we have some of the world's most prominent coronavirus experts on our staff. That has positioned our teams to work quickly to develop and test hundreds of existing and new therapeutics against this deadly virus, as well as to support the development of a variety of vaccine options and antibody therapies. I think the entire Galveston Bay Area region can be exceedingly proud of the work taking place at UTMB and at the other academic medical centers throughout the Houston area. It's important work, and we all take it very seriously. Tonight, UTMB is honored to host this presentation in the Thought Leader Lecture Series. While we can't be together in person, I think you'll find that tonight's speakers have gone out of their way to put together accessible and fascinating overviews of their projects. On behalf of UTMB, I thank you for taking time to tune in tonight. So sit back, get comfortable, and enjoy the presentations.
Hello, I'm William T. Harris, President and CEO of Space Center Houston. Space Center Houston is a dynamic science and space exploration learning destination. A nonprofit science center, we also serve as the official visitor center for NASA Johnson Space Center. We share the story of human space exploration, past, present, and future, with more than 1.25 million visitors annually from around the world through on-site and virtual experiences. Thank you for joining Space Center Houston's Thought Leaders Series program, Humanities Future on Mars, presented by University of Texas Medical Branch. Our series features space and science experts who provide insights and perspectives on space exploration. This year, we celebrate 20 years of continuous human habitation on the International Space Station. Our Thought Leader topics honor the ISS program's many contributions to humanity and its scores of tremendous scientific discoveries and achievements. Space Center Houston is offering a variety of opportunities for you to be part of space exploration. This holiday season, Space Center Houston's Galaxy Lights, presented by Reliant, returns nightly November 14th through January 3rd, 2021. It's an immersive holiday lights tradition, bringing guests the most interactive and technologically advanced light display in Texas. Explore the center in a new way with stunning space-themed light installations, 2 kinetic light shows with suspended moving lights, and photo stations set among actual space artifacts. This year's Galaxy Lights celebrates the 20th anniversary of continuous human habitation aboard the ISS, with an all-new Lights Around the World display surrounding the new permanent outdoor exhibit, a flown SpaceX Falcon 9 rocket. For a list of activities and to purchase advanced time tickets, please visit spacecenter.org. As we navigate this unique period, Space Center Houston is committed to supporting our community with authentic science learning experiences in a safe environment. We're open with new exhibits, new live shows, and spacious outdoor experiences with additional health and safety measures at the forefront of our daily operations. You can save time with advanced time admission tickets. You'll experience one of the most popular experiences, the NASA Tram Tour, which takes guests behind the scenes at NASA Johnson Space Center. Through the Space Center Houston free app, you can also select and reserve seats on the tram tour you wish to board at a designated time, so no more waiting in long lines. Plan your journey with us today. Go to spacecenter.org to review our Know Before You Go guide for information on planning your visit. Space Center Houston continues to offer robust virtual learning experiences for all ages. Register for a virtual campout and gaze at the stars with us. You'll hear from a space expert and explore science activities using household items. We'll make science come to life in your own backyard. Virtual campouts are offered monthly. Or you can take a virtual tour of the museum. Download Space Center Houston's free app for augmented reality videos and audio stories about the future and historic feats in human space exploration. The app is available for Apple and Android devices. Also, learn about activities students and families can do together in the Try This at Home blog series. Follow the Space Center Houston blog on our website or through other social media platforms. To help bring us this content, or bring you this content, we ask that you consider becoming a member or making a donation to help bolster and expand our digital delivery of education resources for the community. Again, you can join or make a gift through our website at spacecenter.org. And now, on with our panel, Humanities' Future on Mars, presented by UTMB. Since Galileo first saw Mars through a telescope in 1610, the red planet has captivated astronomers and explorers. As one of our closest neighbors, scientists hope they can find answers to some of the greatest questions in history just beneath the Martian surface. In our October Thought Leader series, presented by the University of Texas Medical Branch, experts Dr. Kirsten Siebach, Dr. Scott Solomon, and retired astronaut Colonel Bill McArthur will discuss humanity's future on the red planet. Let me introduce our panelists. Dr. Kirsten Siebach is an assistant professor in the Rice University Department of Earth, Environmental, and Planetary Sciences and specializes in Martian geology. She researches source-to-sink sedimentary processes on Mars and early Earth to interpret the history of water and surface environments early in our solar system. She's currently a member of the Science and Operations team for the Mars Science Laboratory rover Curiosity, and previously worked on the science and engineering teams for the Phoenix lander and the 2 Mars Exploration Rovers. Dr. Siebach completed her PhD in geology at Caltech and then did postdoctoral research in geochemistry of Martian sediments at Stony Brook University. Dr. Scott Solomon is a biologist, professor, and science communicator. He teaches ecology, evolutionary biology, and scientific communication as an associate teaching professor at Rice University. Dr. Solomon is also a research associate at the Smithsonian Institution's National Museum of Natural History. He has a PhD in ecology, evolution, and behavior from the University of Texas at Austin, where his research examined the evolutionary basis of biological diversity in the Amazon basin. Before coming to Rice, he worked as a visiting researcher with the Smithsonian Institution in Washington, D.C., and São Paulo State University in Rio Claro, Brazil. Our third panelist, Colonel R Mcarthur, was assigned to NASA Johnson Space Center in 1987 after graduating from the U.S. Naval Test Pilot School and being designated an experimental test pilot. Bill logged 224 days and 22 hours in space, including over 24 hours of spacewalk time during 3 space shuttle missions and 1 long-duration stay at the International Space Station. He made his first flight on board Space Shuttle Columbia as part of the STS-58 crew in 1993. Then he flew on Space Shuttle Atlantis for his second mission, STS-74, in 1995. Bill made his first visit to the ISS in the year 2000 as part of Space Shuttle Discovery's STS-92 mission. He started a 6-month residency on the space station on his final mission, Expedition 12, through 2005. Our panelists will now provide more information about their backgrounds and the scope of their work, followed by a moderated discussion. Our first speaker is Dr. Kirsten Siebach. Dr. Siebach, we look forward to hearing your comments.
Great, thanks for the introduction. I'm excited to tell you about the past on Mars and where we stand now. So if we want to understand the future of this planet and our neighboring planet, we need to be able to look back to the past. When we look at Mars today, we see it's smaller than Earth. It's about half the diameter of Earth. And right now it's quite dry. It's got about 1.6% of the atmospheric pressure that we have on Earth today. That means that while there is water ice on Mars, it's only in solid and gas forms. Liquid water is not stable. So it's a bit dry and unfriendly. But as a planetary geologist, I like to think about the past and think about the path that Earth and Mars have taken to become the planets that they are today. So if we look back, say about 4 billion years ago, the 2 planets probably actually looked very similar. We know that at that time, Mars had liquid water on the surface, just like Earth. And the 2 planets both had the potential for being a site of the origin of life. And we're still trying to understand whether it started on both planets or just one. So if we look at this timeline, we can think about both Earth and Mars formed about 4.5 billion years ago. And so if you look at the upper part of this timeline on Earth, Earth is constantly changing because of plate tectonics, because of abundant water, and especially because of abundant life. And because of that constant changing and recycling of the surface, most of Earth's surface today records the last billion years of history. In fact, only about 1% of the crust is preserved from before 3.5 billion years ago. But around 3.5 billion years ago is the time when we think life started. And it's a time we're really interested in understanding because it gives us the understanding of where we come from and an understanding of what Earth was like early in the solar system. So while it's really hard to understand that time on Earth, interestingly, Mars, which looked very similar to Earth at that time, then kind of dried up. And so if we look down at the bottom half of this timeline, you can see that on Mars, about 75% of Mars' surface is preserving this time period between 3 and 4 billion years ago. In fact, we have even older rocks on Mars than any we've ever seen on Earth. So around that time, Mars kind of transitioned. At one point, it was pretty wet, and we can tell because there's a lot of clay minerals on the surface. Then a lot of that water seemed to dry up because we see these thick deposits of salts. And then around 3 billion years ago, it was pretty dry. And so from then on, we see mostly dust deposits and a lot of wind activity. So we look to Mars because it preserves that time period that we're really interested in around the start of life. And because as we send missions there and try to understand the origin of life and the way that planets work and geology works in the absence of life, we can also understand what Mars is like today and look ahead to the future. And so with those goals in mind, we've sent several different missions to the red planet. We have satellites orbiting Mars, and we also have rovers on the ground. The first rover was a little tiny one named Sojourner, sent in 1997. In about 2004, we sent 2 twin rovers named Spirit and Opportunity. Those are the ones on the left here, and they're about the size of a golf cart, and both of them did a remarkable job, far outlived their predicted 90-day missions, and were able to show us what the Mars surface is like and help us see through their eyes and experience Mars for ourselves. In 2012, we were able to land a much larger rover named Curiosity, or the Mars Science Laboratory. And that's the one on the right here. It's about the size of a small SUV, so this would fill a parking spot. It's quite a big robot, and we got it down to the surface, and I'll tell you a little bit more of the story of what we found. Let me show a map first, showing that we've actually landed successfully on the surface of Mars 8 times, starting in the 1970s. I'll talk a little bit more about what Curiosity found, and then the star in blue is Perseverance, and Perseverance is on its way to Mars today, so we'll look at that one just at the end. For Curiosity, we chose to land in Gale Crater, which is this crater shown here. It's just over 100 miles across in diameter, and it's one of the few locations on Mars that has a really nice, compact set of sedimentary layers, just like the Grand Canyon, where we can go investigate each layer of rock and understand what happened in the past. And this one in particular is special because it contains those major transitions from clays to salts to dry Mars. And so we landed right in that circle shown at the bottom of the crater, and then went over towards the middle where there's a tall mountain called Mount Sharp. Soon after landing, we were able to see up close what rocks on the surface of Mars look like. So here's an example of one of the rocks that was actually cleared off by the blast as the rover landed. And you can see that this is a rock made of small rounded pebbles that have been cemented together. We call it a conglomerate. And the rounded pebbles tell us that water was flowing and rounding these rocks. The size of the pebbles tells us how deep that river was. We use rocks like this to piece together the whole story of what happened here in Gale Crater. So I'll show you a little movie of what happened and narrate kind of the story we've put together with the Curiosity rover observations. So about 4 billion years ago, there were a lot of layers of volcanic rock. 3.7 billion years ago, there was a major impact. You can see the impact was so hard that the middle of the crater actually rebounded up and created a tall central peak. water started coming in from groundwater and from streams off the edge of the crater. That water carried pebbles and sand and mud into the crater where a lake existed for hundreds of thousands or maybe even millions of years. You can see that lake was relatively shallow, but probably lasted for a long time as a lot of the crater was filled with this sediment. The upper part of the crater was probably just filled by the wind. But once the wind filled up a lot of it, then this rock was cemented by groundwater. Later on, the wind regime changed dramatically, and the wind actually came and started blowing material out of the crater. And it didn't just blow away the wind-blown material, it also blew away the deposits from the rivers and lakes. There were different groundwater episodes that helped cement the rocks into place and leave these nice layers exposed, so that in 2012, when we launched the Curiosity rover, we're actually able to land on those sediments and investigate the different layers. Here's one of Curiosity's pictures of those layers. They're absolutely beautiful. So you can actually see the layers of Martian history that are preserved in this crater that we're able to investigate with the rover. And we don't only get pictures, we're actually also able to drill into the rocks and get the chemistry and mineralogy so that we can understand the history of these rocks, and we can show that this lake was actually a place that would have been habitable for Earth-like life. Now, my group in particular, we're interested in studying these sedimentary rocks to understand as much as we can about the whole history of Mars. And so we seek to understand kind of source to sink systems. When we look at a rock in the crater, we can actually use it to understand the volcanoes that produced the rocks outside the crater, the climate at those times when those rocks broke up, the transport processes that either carried the rocks in by water or by wind, and the cementation processes that held that rock in place and froze it for us to be able to examine billions of years later. And in Gale Crater, we've been able to see examples of all of these rocks, and we're working on interpreting those. This understanding of the history also leads us to understand what will happen in the future and have a better understanding of climate change here on Earth, as we can understand climate changes on other planets as well. Finally, we're looking ahead to the Perseverance rover, which will also land in a crater that used to contain a lake. This one's called Jezero Crater, and you can look forward to February 18th, 2021, when the Perseverance rover will land. And this rover's big task is to collect some pinky-sized rock samples, which it will be able to return to Earth, which a few following missions will return to Earth over about the next decade. And so we're looking forward to that and looking forward to continuing to increase our understanding of Mars and what it'll be like for people.
Thank you, Dr. Siebach. That was absolutely fascinating. I'm looking forward to our Q&A a little bit later. I have a number of questions about the formation and evolution of Mars. Our next speaker is Colonel Bill McArthur, retired astronaut. Bill, we look forward to your remarks.
Thank you so much, William. You know, I feel a little, we've heard the expression, a rose between two thorns. I feel a little bit more like a thorn between two roses, being between Dr. Siebach and Dr. Solomon. And gosh, just such fascinating information. So to explore Mars, for people to explore Mars, we have to be able to get them there. And so we do that, we gain that knowledge through our current space exploration. Here you can see today and the future, at least the relatively near future of human space exploration as we operate the International Space Station. And one of the primary reasons we're doing that is to understand how to keep people healthy and productive on the long journey to get to Mars. And as an intermediate goal, we hope to begin to explore the moon and establish a permanent human presence on the moon. I like to maintain, though, that people have been exploring space for a very long time, at least in their imaginations. Jules Verne wrote From the Earth to the Moon nearly 100 years before Apollo 11. What an incredible mind he had. And then H.G. Wells wrote that the first men in the moon at the turn of the 20th century. But it is an environment that our bodies really aren't completely adapted to. One of the things that all us rookies, and this is my first flight, all us rookies do is we want to see how we change in space. And here I am doing what? I'm measuring to see how tall I became. And I grew about 1.5 inches when I was in microgravity. So most of what we do on the International Space Station, or much of what we do, is to try to understand how the human body changes as it adapts to that environment. And we take countermeasures to try to maintain our health, because some of the effects of being in microgravity, while they are subtle, do impact an astronaut's or a cosmonaut's health. One of the things we try to do every day is exercise extensively, and exercise in space is different. If you think about exercise on the Earth, generally we exercise by fighting against gravity. And so how do you do that if there is no gravity to hold down as you run? Here we can see Valery running on a treadmill. Here I am riding a stationary bike. Now, if you notice, both Valery and I were not perhaps dressed in the most comfortable fashion, because not only do we exercise to maintain our fitness, but scientists are really working hard to gather data so that they can understand how effective the exercise is. And so now we come beyond the moon, and here we have authors such as Andy Weir in his book, The Martian, gosh, which was only published 6 years ago, and maybe you've even seen the movie. And I tell you, I really like this book. I think it helped inspire me to think what life on Mars might be like. I did have one bone to pick, however. What's it like to go outside on another planet? Well, I certainly don't know. This is Buzz Aldrin during Apollo 11 on the moon, and we looked at him, and you could see both Buzz and Neil are bounding along on the surface of the moon, and it looked so easy. It is not easy. It's very difficult to simply put on a spacesuit before going out to do a spacewalk or a moonwalk. And it will be difficult to do a Mars walk. And certainly in The Martian, Watley was going outside multiple times per day. I'm just not certain how difficult that would be. And even being outside itself is very intense work. And so being able to do multiple spacewalks on consecutive days or multiple spacewalks on a day may be more physically demanding than, than our astronauts will be able to do, which will really necessitate relying on things like robotics. But what I really talked about is getting to Mars and maybe spending a short period of time on Mars. I mean, the first mission to Mars will need a surface presence of about 15 months until the alignment between Mars and Earth are such that a return trip is possible. But what about people living on Mars for generations? And so I turn again to a book written in 1961 by Robert A. Heinlein, Stranger in a Strange Land. And it was about a gentleman named Valentine Michael Smith. An earlier title of the book was A Martian Named Smith. And this is about a young man who was born on Mars and was raised by Martians and then returned to Earth. And he was different. And so I will be very interested to hear Dr. Solomon's thoughts on what it will be like when people are living on Mars. And just like the imagination of authors generations ago, I think inspired people inspired the space program we have today, I think the future is wherever our imagination takes us.
Absolutely
And that's
fascinating.
my
Well,
last
thank you
slide.
so much for your interesting comments. And I also am really curious about what will happen to us in the future if we have humans living multi-generation on Mars. Our next speaker, Dr. Scott Solomon, is an evolutionary biologist, and perhaps he can answer some of those questions. Dr. Solomon.
Thank you so much. It's really an honor to be here, and I've really enjoyed hearing what Dr. Siebach and Colonel McArthur can tell us about thinking about some of the challenges associated with getting us to Mars and some of the conditions that we may find when we do get there. I want to share a little bit of my perspective as an evolutionary biologist, and to build off of what Colonel McArthur said about how science fiction authors have imagined the future on the red planet, and talk a little bit about how we might be able to use what we know about evolutionary biology to make scientifically informed predictions about what that future might look like. So to start off with, let me tell you a little bit about my own background and how I became an evolutionary biologist. As a kid, I was, like many kids, just fascinated by the outdoors, and I was always exploring in my own backyard and looking at things like ants and trying to figure out what they were up to, and always out exploring and curious. When I went to college, I thought that I would end up studying medicine, because at the time I was under the impression that if you like biology and you want to have a career, that you become a doctor. But I had an opportunity while I was in college to be a research assistant in the Galapagos Islands and actually do field work studying marine iguanas. And this completely changed my life. I immediately saw how exciting and fun it could be to have a research career studying ecology and evolutionary biology. And so I decided to change paths and start focusing on biology. So I went off and went to graduate school in ecology and evolutionary biology, and I ended up returning to one of the fascinations I had as a kid, ants. I ended up studying the ecology and evolution of ants in the Amazon basin, and starting to ask questions about how the incredible diversity of life that we see in the Amazon basin today came into existence in the first place. So I started to understand more about the evolutionary process by which species come into existence. Now, as a professor at Rice University, some of what I'm doing is trying to apply what we've come to know about evolution to understand people. And that includes not only trying to understand how we got here, but also where we're going. So to try to think about how we can predict what our evolutionary future might look like. And in this context, I've gotten really interested in the question of what could happen to our descendants many generations in the future if we end up establishing permanent self-sustaining colonies on Mars. Now, luckily, as we've heard, we know a lot about what happens to the human body and mind in space from studying astronauts like Colonel McArthur and others who have spent time in low Earth orbit, and that includes on the space shuttle and more recently on the International Space Station. One of the recent studies that has really given us a lot of insight into exactly what types of changes happen was the twin study that looked at astronaut Scott Kelly during the year that he spent in space on the International Space Station in 2015 and 2016. And part of that is because we were able to make comparisons with his twin, Mark Kelly, who stayed on Earth. And so by comparing the changes in physiology and genetics that happened to Scott Kelly while he was in space to what happened to Mark Kelly back on Earth, we could really see what the differences are and how the body is affected, including at the level of DNA. So one of the things that we know happens in space is, of course, that the body is subjected to lower gravity. And Colonel McArthur was talking about how when he returned from space, he was actually taller. And that is something that many astronauts experience, because without the force of gravity pushing down on the body, the body actually starts to expand a bit. So our bodies are actually really adjustable, or plastic, as we say in biology. And so that is one way in which our body is affected. But another thing is that the muscles and actually bones start to become a bit weaker, even with the exercise that astronauts perform on a regular basis in space. The bones are still a bit weaker when they return to Earth than they are when they left. Now, another effect is the effect of radiation. So we know for example, by looking at Scott Kelly's DNA before and after his time on the space station, that the radiation in space, the galactic cosmic rays and solar particles and ultraviolet radiation that luckily we're protected from here on Earth, are still impacting astronauts on the International Space Station, even though the International Space Station is partially protected by the Earth's magnetosphere. But we actually saw evidence of genetic changes to Scott Kelly's DNA from the year that he spent on the International Space Station. So that's really informative in thinking about how the body is affected by the conditions of space. But Mars is different from low Earth orbit. For example, there is more gravity. Mars has about 3/8 the gravity of Earth. So people walking on the surface of Mars would be able to walk around. It would be different from Earth and different from the moon. But this means that we have to think a little bit differently about how that lower gravity would affect the body. Nevertheless, the same weakening of muscles and bones is expected to occur. Also on Mars, there is no magnetosphere at all. And there's only a very thin atmosphere, as we heard from Dr. Siebach. So that means that the radiation from space is hitting the Martian surface at almost full strength. And that is going to be a very big challenge, as we heard from Colonel McArthur, for anyone who wants to spend any amount of time on the surface. So Martian settlements are likely going to need to either be underground or to have some built-in radiation barriers. But I don't know about you personally, I wouldn't want to go to Mars if I don't get to spend at least a little bit of time out on the surface. So I would imagine that people living on Mars, even if it's only to get out and see something different, are going to want to spend at least some time up on the surface. That means they're going to be exposed to that radiation. So how can we think about what we can apply from our knowledge of evolutionary biology to make predictions about how people would change in the future? This is where I like to apply what we know about species like the Galapagos finches that live on the Galapagos Islands, because not only were these finches a part of what inspired Darwin to develop his theory of evolution by natural selection, but they've also been one of the best examples for biologists today to study the process by which evolution happens. And so what is it about the Galapagos Islands that has made them such a natural laboratory and such a productive laboratory for studying evolution? Well, the key factor is isolation. Isolation of a population of birds, for example, on one of the Galapagos Islands, means that anything that happens to those birds is going to be confined to that one island. And we know that mutations are a natural part of life. They happen periodically, randomly, all the time. And while some mutations are harmful, some on occasion can be beneficial. And the different shapes and sizes of the Galapagos finches have adapted them to different types of food because mutations have occurred in the finch's DNA that has given them a slightly different beak, shape, or size, and that has been an advantage that was passed on to their offspring. So this key factor of isolation on islands has meant that the finches in the Galapagos have been able to adapt to the unique conditions there. And what we see now, looking back, is that 14 species of finches in the Galapagos Islands have evolved through this process of mutation and natural selection, all of which can trace their ancestry back to a single finch or single population of finches, just one type, that arrived in the Galapagos Islands somewhere between 1 and 2 million years ago. So these key factors of isolation leading to mutation and natural selection accumulating differences, that's not unique to the Galapagos Islands. That's a process that happens on islands everywhere. And if we think about it, the planets in our solar system are really like islands, just on a much larger scale. So what that means is we can think about the same processes that affect finches in the Galapagos affecting people on Mars, because we will have the same isolation and we will experience both mutation and natural selection in different ways on Mars than we experience it here on Earth. So what might be some of the ways in which our species could change by living on Mars? This is where we can speculate, but we can use a little bit of informed speculation based on what we know has happened to species, not just our own, but other species here on Earth. So I'll give you 3 examples of possible changes that could happen to our descendants several generations in the future on Mars. So the first is that the lower gravity on Mars, again, is likely to make the bones of people living on Mars weaker. Now, this is where science fiction writers have imagined people becoming kind of long and thin and sort of spindly, and that's the classic image that we often have of what a Martian might look like. But I think there might be a key part of the human life cycle that is forgotten in that imagination, and that is that childbirth imposes a major restriction on the shape and the form of the human body. And although the force of gravity would be less, women experiencing childbirth would still be experiencing forces on their body that would be potentially dangerous if they had weakened bones. So you could imagine that females living on Mars might actually evolve to have stronger, denser bones so that they can afford to lose some bone density as they age, so that by the time they reach their childbearing years, they would be able to survive through the childbirth process. Another possibility is that the radiation on the surface of Mars could actually increase the mutation rate. We know that radiation causes mutations. And so if people living on Mars are subjected to higher doses of radiation than on Earth, then we actually would expect that the rate of new mutations would be higher on Mars. And that actually could accelerate evolutionary change. One of the possible changes out of many that could happen would be changes that would actually help protect us from radiation. So here on Earth, we know that humans and many other species use pigments to protect us from radiation. And so that includes the pigment eumelanin, which is in our skin and provides us with some natural protection from ultraviolet light. Some species have different types of pigments. So the pigments called carotenoids, which are what carotenoids give carrots their orange color. Some species use carotenoids as UV protection. And most animals, including us humans, we get carotenoids from our diet. We can't make those carotenoids ourselves. But we actually know of some insects, a type of aphid, that have acquired the genes to make carotenoids themselves. And when that happened, they actually turned orange. So there's a precedent here on Earth for species evolving to have new types of pigment and being able to produce them themselves and becoming a different color. So maybe rather than little green Martians, we could actually have orange-skinned people on Mars. So the third example I'll give of a possible way in which humans could change on Mars is a bit more subtle. It's not something you would necessarily see from looking at a person. And that has to do with the microbiome. The microbiome is the collection of all of the microorganisms that live in and on the human body. And of course, we take our microbiome with us everywhere we go, and we would be taking our microbiome with us as we travel from Earth to Mars. And we know from studying astronauts that when they go to the International Space Station, they take their microbiomes with them too. And in fact, part of the twin study was to look at how Scott Kelly's microbiome changed while he was in space. So some likely ways in which it would change is, first of all, reducing the diversity of microbes that live in and on the body. But the thing is that we actually depend on many of those microorganisms to help us with parts of our physiology. So they help in digestion and immune response and even regulating hormone levels. We also know that microbes can evolve in space faster than they evolve on Earth. And that sets up an interesting possibility, because it could mean that the microbes that are living in and on our bodies start to mutate and evolve in ways on Mars that maybe make them more like germs, more like dangerous pathogens than harmless passengers or even beneficial members of our microbiome as they are today. And if that happens, it could actually mean that people living on Mars will evolve immune responses to those microbes. That is, the immune responses would be different from what people back on Earth have. And that's sort of reminiscent of the way that the first Europeans who arrived in the Americas brought diseases with them to the Americas that Native Americans didn't have any immunity to. And of course, that led to devastation. So we might actually choose to enforce separation or isolation, a type of quarantine between people living on Mars and people living on Earth, so that we don't infect each other with our diseases. But if that happens, that actually sets up a scenario where it further exaggerates any differences that were coming into existence anyway through mutation and natural selection. And so what we see in the future then is a situation where, just like the finches in the Galapagos Islands, people isolated on Mars and people isolated on Earth could evolve to actually become different species. That's really interesting because it's kind of an ironic twist, right? There's this notion that one of the reasons we should go to Mars is so that we can establish these long-term permanent settlements there. Stephen Hawking once said that our only chance of long-term survival is not to remain inward looking on Earth, but to spread out into space. So it's really ironic then if our efforts to preserve our species in the long run ultimately end up changing us forever.
That was absolutely fascinating. Thank you so much to all of our panelists. And now we have my most favorite part of these Thought Leader programs, when I get to ask a few questions. So many interesting topics that we've covered, and I have so many questions that I'd like to put out to our panelists. I think I want to go back actually to Kirsten and ask her about the Ingenuity Mars helicopter that's going to be a complement to Perseverance, and kind of her thoughts on how that technology can help assist in exploring Mars, and what kind of questions you hope that the helicopter can help answer.
Yes, Ingenuity is a small drone that will kind of hitch a ride with Perseverance to Mars, and probably ride on Perseverance for a little while after Perseverance lands, and then it will separate from the rover, and Perseverance will drive on, and then this little drone named Ingenuity will fly up in the air and be able to take pictures of the surface of Mars before coming down and landing. This is going to be a really exciting new way to explore Mars. Ingenuity is what we call a technology demonstration, and so we're kind of proving that the concept works. So even with Mars's atmosphere that again is around 6 millibars, or 0.6% of the atmospheric pressure that we have here on Earth, we can now develop miniaturized technology so that we can have a drone that can actually fly a camera above the surface of Mars, and we'll prove that with Ingenuity, and hopefully that opens the door to drones on Mars in the future. And we can think about different styles of missions, like instead of having one big rover, maybe we could send drones to a lot of places or monitor the weather. I really think that will lead to new kind of mapping applications, new understanding the weather on Mars, and new ways to understand a lot more of the surface of Mars than we have so far.
So I'm curious, the United States is not the only country sending vehicles to Mars now, right? We recently had a launch from China. There's a partnership between JAXA in Japan and the United Arab Emirates. And right now, Mars overall is fairly pristine because we haven't sent, there have been 8 missions, you said, that have successfully gotten to the Martian surface. Is there any kind of a corridor way to prevent contamination so that we're not somehow bringing materials to Mars that give us incorrect information, that we're detecting residual things that we're bringing from Earth?
Yeah, absolutely. As scientists, we're really concerned about contamination. You know, for the first order, we don't want our experiments to go wrong. We don't want to go check if there's life on Mars and accidentally find that we brought a bug from our laboratory here on Earth. And so in order to avoid that, we're always checking for cross-contamination. But beyond just the science and beyond the individual emissions, we do have to think in the bigger picture when we're thinking about astrobiology on other worlds and kind of the possibility of finding life on other planets. And Mars might be our closest and best chance for that. And so there is a treaty called the Outer Space Treaty that all of the spacefaring nations have signed to be really careful to limit both forward contamination, which would be terrestrial contamination of Mars with our microbes, and backward contamination, which would be bringing some kind of unsealed Mars sample back to Earth, because we don't know if there's some kind of virus. We just don't know what is in the Martian soil well enough to want to just expose it to the whole planet. And so we follow those planetary protection agreements by which we sterilize our spacecraft and we protect any return samples from exposure to the environment. But if we send people, this is going to be something that we really have to think about, because people are covered in microbes, as Scott was just saying, right? We have these detailed, complex microbiomes on the inside and outside of humans, and we can't exactly sterilize ourselves. So we really need to study Mars and the way that things get transported around Mars, as well as kind of our enclosures and our spacesuits and everything we can do to limit our forward contamination, so that we can still use Mars to understand our universe and life better by searching for possible life there.
Yes, I was actually thinking about the tardigrades on the moon after the Israeli probe crash. So anyway, that was kind of the reference of it. That's absolutely fascinating. I wanted to ask Bill McArthur about his experience as being an astronaut, if he could share things that we've learned about how astronauts' physiology has changed. I mean, Scott spoke a little bit about what happened with Scott and Mark Kelly and the twin study that took place. But what are some of the other things that we're learning from astronauts living in low Earth orbit? And now, of course, the missions are 6 months, and we're planning to establish a long-term presence on the moon, on the South Pole. So Bill, if you could tell us a little bit about that. But I'm also curious to know about, did you experience any, not only physical, but cognitive effects of living for an extended period of time in microgravity?
Thanks, William. So a lot of the effects, I mean, when we look back, we've been flying, humans have been flying in space for 59 years. And so we do have a lot of data about living in microgravity. Although I think you may have pointed out earlier, we're about, well, gosh, a week or so, a couple of weeks away from the 20th anniversary of the first permanent crew going to ISS. And so we now have 20 years of continuous data. And if you might think, well, certainly we learned everything in the first 40 years. And the answer is no, we haven't. We're still learning new things. And some of the things that we discovered, and Dr. Solomon pointed them out, we know about bone demineralization, we know about muscle atrophy, and we've gotten very good at addressing those primarily through diet and exercise on board ISS. You ask about cognitive issues. A good friend of mine and another former astronaut, Jim Voss, said that his experience was he left about 50% of his intelligence on Earth. And so I think that's particularly true in the first part of your space flight, of your mission, because your body is a little bit, and intellectually, mentally, you're a little bit distracted by all the newness. Now, you can, over time, that changes. You really become very, very good at it. And if you observe astronauts in video downlink on board ISS, you can very quickly identify someone who is in space the first time in the way that person moves around. they tend to do the Superman zoom and be horizontal and be kind of flying along sort of like a human torpedo. And it's a lot of fun to do, but it requires a lot of extra effort. And instead, you'll see someone who's very experienced move laterally a lot or move vertically a lot from one work site to the next work site, especially if it's along the same wall or from one wall to the other, or if they're going from one of the walls to the overhead or to the deck. They again are very efficient in their motions. Now, we've also discovered some neurophysiological issues. We actually had, shortly after I got on board ISS, the doctors on the ground just had observed the first known instance of spaceflight associated neuro-ocular syndrome. And it has a lot to, it manifests itself in changes in vision, sometimes permanent changes in vision. And so there are a lot of things that happen to the human body, and will they, if you spend generations exposed to those factors, you know, would you expect to see adaptive or evolutionary changes begin to manifest themselves? I think perhaps you would. You know, if you think about it, though, who are we going to send to Mars? We have to be very selective in who we send. So to deal with the radiation issue, one question is will we screen people for familial history of cancers that are particularly sensitive to radiation exposure? And if we start doing that type of genetic screening, isn't that like a sort, aren't we doing a bit of genetic manipulation, if you will? And that, you know, it's sort of, gosh, I hate to compare it to, you know, livestock breeding, but, you know, we certainly select animals for breeding where we want to promote certain characteristics. I mean, whether it's in livestock or whether it's in golden doodle dogs. And so I think we will begin that evolutionary process in the astronauts that we select to go to Mars.
Well, that is a huge ethical issue. And actually, I think it's something we deal with now. I mean, with the CRISPR technology, we can edit genes, right? And so there's the whole ethical discussion currently on Earth about, well, with CRISPR, could you adapt characteristics of your unborn child? Or could you, perhaps in a positive way, identify a defective chromosome that causes sickle cell anemia and be able to repair that? So I'm curious, and I'd like to put this question out first to Scott Solomon, Dr. Solomon, around the kind of ethics is thinking around, should we use CRISPR in a way to adapt humans to prepare them to be more successful on Mars, and all of the consequences of the environment there, or the issues that we're not adapted to survive in or live in?
Yeah, I think it's a really good question and a really important question. But I actually want to back up just a sec to address what Colonel McArthur brought up, because I think it's related, right? The selection of who you send to establish a what would ultimately become a new population of humans, no matter how you do it, you will be making choices that would influence the future of that group of people. It's actually yet another well-known phenomenon in evolutionary biology on Earth, which we call the founder effect, or the founder principle, by which anytime you take a small number of individuals and they go and they establish a new population on an island, like if there's a volcano that pops up out of the ocean and becomes a new island, the first individuals that arrive are unlikely to be representative of the larger group that they came from. And so you have just this phenomenon by which the individuals, whatever the traits that they happen to possess, are the traits that are going to be common in the new population. So even if we're not intending to, even if we just essentially do the same types of screening that we do for astronauts today. Just try to choose people who are going to perform well, the tasks that they need to perform, and who get along well with other folks on their crew, and all of those types of things that we know are important. That would be inadvertently sort of steering the future of that population in a particular direction. Another thing that happens with that is you've reduced the amount of genetic diversity in the population. And one of the consequences of that is that natural selection only works well when it has a lot of variation to work with. So the more variation, the more potential for future adaptation in later generations. So what we actually might want to do would be, rather than just to screen for particular traits, we might want to cast as wide a net as possible and try to make a Martian colony as representative of all of humanity as we possibly can. Not only because that might be a good thing to do from a moral and ethical perspective, but also because it could give our descendants in the future the greatest chance of being well adapted. But just to get to the question more directly about making deliberate edits to the genome using technology like CRISPR, I think you're right that if we get to a point where we can do that safely and effectively, it would be a really important thing to do. If we knew, for example, how to minimize a person's chance of being negatively affected by radiation, right? Getting radiation poisoning or developing cancer from radiation exposure on Mars, then I would say that we absolutely need to be intervening in a way to protect that person and their descendants. But the problem is, even though we have the technology today to do the edits, we're still missing two key pieces before we're ready to do that type of thing. And they are, first of all, which changes to make. So you mentioned like sickle cell is an example of a genetic condition for which the genetics is very well understood, and it's actually just a single DNA base change that is the difference between having sickle cell and not. And so we can go in theory, and make that switch. We know what switch to make and potentially cure a person of the condition. And if you make it in a way that it's heritable, all of their descendants would be cured as well. So we have to know what change to make, first of all. And for most traits that we're interested in, including a lot of the things like how to protect ourselves from radiation, we don't yet know enough to be able to make those exact changes. But the other problem is we need to make sure that it's safe. We need to make sure that making those changes don't have any unintended consequences to other traits. And that's where we really need to advance our understanding of genetics far beyond what it is today, before we could confidently say that making a change in one particular gene isn't going to have negative consequences for other genes. But if we get to that point where we can say it's both safe and effective, then I think it could be actually a really important tool in helping people to maybe even be pre-adapted to the conditions on Mars and accelerating the process that would otherwise play out naturally.
Well, it's fascinating because you think about the randomness of life, right? And so life likes to have lots of paths and ways of moving forward, and is always evolving and adapting. And it's why we have these new SARS viruses, right? They're always, it's another thing that's trying to thrive in some way in life, and some of them benefit us and some of them don't. They're kind of harmful to our organism. And so it is fascinating to think about, when you start manipulating at that level, what those consequences could be. I'm curious, going back to Kirsten about Mars, because there are conversations about, well, could Mars at some point in the future become habitable, right? There's a conversation about the sun is slowly expanding, and so the habitable zone might be shifting, where Earth will be getting too hot and dry, and maybe the frozen water on Mars could melt, and maybe the lakes again could have water, and maybe a cycle could begin. Do you think at some point in the future there's indication or evidence or possibility that once again Mars could become habitable to life as we know it?
Oh, interesting question. As we think about the past and we look at geology, there have been these remarkable, huge changes on both Earth and Mars in the climate and what's happening on the planet. And so, in some ways, there are things that we would probably find unpredictable as we move forward. However, Mars is smaller than Earth, and it's developed a much thicker crust. And so volcanism is very infrequent. We do think there's maybe been a couple of eruptions, but not too much happening over the past kind of hundreds of millions of years on Mars. And so because of that, there's a lot less geologic activity, and potentially it would be more of a challenge to get Mars to a habitable state than just having kind of a brighter sun or more radiation reaching the planet. You do have somewhat substantial water at the poles and carbon dioxide in the atmosphere today, but without that kind of recycling process. On Earth, plate tectonics is that long-term recycling process that keeps the atmosphere sustained, right? Because volcanoes erupt, and then as the CO2 sinks into the ocean, it gets pushed down into the mantle again, and the volcanoes erupt again. You have a much more long-term sustainable cycle. On Mars, even if you try to do something manual to terraform the surface, without that cycling process, whatever you put into the atmosphere is going to kind of react with the surface or escape into space. And so long-term, it's unlikely to become a sustainable Earth-like location.
Fascinating. While we're talking about Mars and humans evolving and living on Mars, I'd like to kind of switch to the moon, because it's currently NASA's priority through the Artemis program to return to the moon very soon, in about 3 years' time. And the intent is to have some type of long-term human presence on the South Pole. And then, of course, the recent discovery of ice crystals, not only in craters, but also on the surface of the moon. I'm curious about all of your thoughts on what you hope we're going to learn from having humans having kind of long duration on the surface of the moon. How can that help inform our intent to send humans to Mars?
I can start briefly just to say that once you have a human base on the moon, I've long said that if you want to see humans on Mars, the first thing that you should look for is having a base of people on the moon. So when we're looking out ahead to Mars, you really need to be able to kind of launch to Mars with all of the equipment and food you need to last for probably a 2-year mission minimum, just based on the orbits of Earth and Mars. And you need to be able to live far from communication with Earth. And so those astronauts have to be very independent. And so before we're going to send this colony to live on Mars, we really need to have that base on the moon, both to launch from, prepare at, and learn from generally, so that so that we can practice, basically. And so I always say, if you're looking out, thinking of when can we be on Mars, just look for that colony on the moon to start. But I am really interested in Colonel McArthur and Professor Solomon's thoughts on that.
I couldn't agree with Dr. Siebach more vigorously. I think she nailed it. She said almost everything I would have said. So I think part of it is we set an expectation. When I talk about how long human beings have been flying in space, part of the message is the reason we will keep doing that is because that is an expectation for humanity as a whole. And we talked about other, I think, William, I think you mentioned other nations are sending robotic vehicles to Mars. And we know just recently the Chinese landed on the far side of the moon. And so I think as a species, we now vision ourselves as spacefarers. And I don't think that we would be willing to settle in taking a step back and keeping all our ships in the harbor instead of sending them out to explore. And I think a key part of that will be when we set an expectation that people are doing more than orbiting the Earth, that we have more than astronauts and cosmonauts who go to low Earth orbit, and maybe they spend 6 months, maybe they spend a year, but they're coming back. maybe we ought to start with the expectation that people will be living on a heavenly body that has been a focus of humanity for all of recorded and pre-recorded and prior to recorded history. And I think just as Kirsten said, we set that expectation. We proved we can do it on the moon. We developed the techniques and the technology on the moon where if something goes wrong, we have a reasonable chance of being able to recover the people that are involved before we take that. I mean, that's like that's a step off a huge, when we say we're going to go to Mars, because once you start, you can't turn around and come back. You are committed for months. You're committed for 2 to 3. This is a 2 to 3 year commitment before you can bring someone back, and you absolutely can mount a rescue mission.
Fascinating. Scott, what are your thoughts?
Yeah, so I totally agree with everything that's been said as well. I'll add 2 specific things that I think we may be able to learn about how our bodies are affected by life beyond Earth from having a longer term presence on the moon. One is, as I mentioned in my opening remarks, the International Space Station is in low Earth orbit, which is close enough to the Earth that it has some radiation protection, whereas the moon has a lot harsher radiation exposure. And so I think one of the things that we'll be getting a better sense of is the reality of how that radiation affects our body and how effective we can be at screening it. So I think we'll learn a lot more about the effects of radiation on the human body from being on the moon. But the second thing is that, most of what we know about how space affects the human body comes from studies of adults and healthy adults for the most part. And so if we're serious about wanting to have a permanent self-sustaining colony on Mars, we actually need to know how everyone is affected by those conditions. We need to know, for example, what does childhood look like on Mars? What does childbirth, what does pregnancy look like on Mars? Those are obviously, key components of the human life cycle, but also things that we need to understand in order to be able to responsibly say that we're going to, be having people have children on Mars. So we need to know, like in the stories from science fiction, does a child who's born on Mars, do they change in drastic enough ways that it would be impossible for them to return to Earth because, for example, they wouldn't be able to tolerate the increased force of gravity? We have to know that before we, I think, can reasonably to talk about having children on Mars. So maybe if we have the opportunity to bring people of all different ages, all different types of people to the moon for relatively shorter periods of time under more controlled conditions, then we might be able to learn more about how it's likely to affect their bodies when we get to the conditions on Mars.
I mean, that is absolutely fascinating. I was actually going to go there with that question because you think about the development, for example, of vaccines. We're all right now all hopeful around better therapeutics and some type of vaccine against coronavirus COVID-19. And one of the big issues in the trials is having enough variety of people as part of those trials, right? People of different body types and ethnicities and ages. And then you get into the whole kind of ethical issue of children, right, as test subjects. And you're absolutely right. We really have to understand how people in different phases of development as a human are going to respond or react their bodies physiologically to these different environments. And that is a huge unknown. And even with animal models, it gives you some indication, right? But it's never quite the same as it being in a human. There's a lot of great data that you can get from animal models, but in the end, you really just don't know until you do it or try it on a human how it's going to play out. Well, I'm so sorry to say that we have come to the close of our time. I could keep going on with many more questions. This has been an absolutely fascinating conversation. I do want to give each of our panelists a moment to share any closing thoughts before we conclude our conversation today. And maybe we'll begin with you, Kirsten, if you have any closing thoughts you'd like to share.
Oh, I just love to think about these questions and think about the future of exploration. And I guess one thing that I'm really looking forward to right now is the landing of Perseverance on Mars and that flight of ingenuity that we talked about, because that'll be the first step to bringing samples back from Mars. And we definitely want to establish that technology before sending people. And so just in terms of something tangible to look forward to over the next few months, February 18th, 2021, the Perseverance rover will be landing.
Wonderful, thank you. Bill.
So, gosh, just think, what are we, less than 3 weeks away from the launch of SpaceX Crew 1, and we're seeing an acceleration in our ability to explore space, and I think it's it's so exciting. And we sometimes though have to ask, why are we doing this? And one of the best things I ever read was by Mike Griffin, the former NASA administrator. And he said that he was convinced if NASA were to disappear tomorrow, that Americans would feel we had lost something that mattered. And I think you can really extrapolate that to internationally to the family of nations, that it is that space exploration is important to how human beings, how we feel about ourselves, and our belief that there are no problems so great that if we come together, we can't solve them.
Wonderful, thank you. Scott.
Yeah, I think it's clear we're living in an absolutely exciting and exceptional time when it comes to what we're learning about space and in our ability to get out and explore space. So I'm personally really excited about the near term and the longer term future in space. And one of the things that I tried to highlight in my presentation here is that we can actually learn a lot about our future in space by studying the species right here on Earth. And there's more that we need to understand about those species. And that actually brings me to a point that I want to make that I think is relevant for our conversation. And that is that I know that sometimes people worry that in our efforts to explore and understand other planets like Mars, that we might be somehow forgetting about Earth or ignoring the problems that we have here on Earth. But I personally feel like it's actually the opposite. I think the more that we look outward and explore Mars and our solar system and beyond, the more we recognize how special Earth is, how valuable and important it is to protect our planet, because it is so perfect for us. We, at the end of the day, are very well adapted to living here on this planet, and it's important that we try to protect it as best we can. So I'm optimistic that we can have a future that includes space exploration and perhaps colonization, but also protecting what we have right here on Earth.
I think that's the perfect closing comment, because I concur and feel the same. And I think that is the great value of space exploration, is that it helps us better understand Earth and Earth systems and actually develop solutions for a lot of challenges and problems that we face on this blue marble, which is also a spaceship that we all reside on. And so, again, I want to thank our panelists today, Dr. Kirsten Siebach, Colonel Bill McArthur, and Dr. Scott Solomon, for their incredible thoughts and insights. And I expect great things from all of you still in the future. We'll continue to follow you in all the incredible research that you're doing. And I invite our guests who are watching this to tune in for our future Thought Leader programs. We hold these monthly, where we continue to bring you individuals who are really on the front edge of talking about all these incredibly interesting issues related to space exploration. So thank you for joining us.